Computer Organization and Security. Unit number 2, Basic Computer Organization and Design. The name of topics are Instruction Cycle and Interrupt Cycle. In this video, we are going to cover about instruction cycle, interrupt cycle, and a complete computer description. Instruction cycle is a steps executed to solve a computer instruction. Interrupt cycle is a one type of hardware implementation of a branch and save the return address operations, and complete computer description with a combination of both instruction cycle and interrupt cycle. We are going to discuss about instruction cycle, fetch and decode, memory reference instruction, input output instruction, interrupt cycle, and complete computer description. These are the topics from Unit 2. First, instruction cycle. So basically, what is the instruction cycle? So a program is executed in the computer step by step. That all the steps are known as when a computer goes through all the steps, then it is known as a cycle. So a machine instruction is executed in the following steps. The first is fetch an instruction from the memory. Second, decode the instruction. Third, read the effective address from the memory if the instruction has an indirect address. Fourth, execute the instructions. So these are the basic steps to execute any instruction cycle. First step is to fetch and decode. So at the timing signal T0, that means at the first timing pulse, how to fetch or decode the instruction. So first, the instruction which we want to fetch, the address is stored into the program counter. Okay. So from the program counter, that address is going to load into the AR. That is the first step. Now the second step, that means at the time of T1 pulse, from the memory, whatever address is stored on the AR, come on that particular address, and from memory take the data and load that data into the IR through this common bus. At the time of T1, from the memory, move on the AR register, move on the address stored in the AR, take the data from this particular place and load into the IR. So from memory unit, the data is going to copy. From the memory unit, the data is going to copy to IR. At the same time, program counter, it is incremented by 1. Now, at the third timing slot, at the time of T2, whatever instruction is loaded into the IR, that instruction is divided into 3 parts. That is called the decode. First 0 to 11 bits, that means first 12 bits are stored into the AR, 12, 13 and 14, that is stored from D0 to D7, and 15th number bit, that is stored into the I. Now the same thing is going to explain through the flowchart. First, the instruction is going to execute when the value of sequential counter is equal to 0. At first, at the time of T0, The value of program counter is going to load in AR at the timing of T1. That uh, address, memory address, take the data and store into the IR. At the same time, program counter is going to increment these two things, that is a fetch instruction at the time of T0 to 1. At the time of T2, decode. Decode, that means divide the instruction into three parts. So IR, that is in IR, whatever instruction is going to execute, it is stored. It is divided into three parts. 0 to 11 are stored into AR, 12, 13, 14 are stored into IR, and 15th number bit is stored into I. Now, depending upon the value of D0 to D7, the computer is going to identify that which type of instruction is it. If the value of D7 is equal to 1, then that means if the value of 12, 13, 14, that is triple 1, then it may be register reference or input output. And if it is not triple 1, that means from 000 to 110, then it is a memory reference instruction. So if D7 is equal to 1, then it may be register reference or the input output reference. At the same time, if the value of I is equal to 1, then it is an input output instruction. It is going to execute input output instruction. If the value of I is equal to 0, then it is going to execute register reference instruction. And for the memory reference instruction, if the value of I is equal to 1, then it is an indirect memory reference instruction, and once again going to take the data from the address stored at the AR. And if the value of I is equal to 0, then it is a direct memory reference instruction. So in both the steps, finally it is going to execute the memory reference instructions. Now, which are the memory reference instructions? See here. Here, memory reference instructions are going to execute from the timing slot T4. Okay. So now, execute memory reference instruction. Then we are going to discuss. First is a AND operation, AND to accumulator. So at the for the AND operation, D0 is going to select. So at the time of T4 and D0, memory of address register is going to stored in DR. Okay. So from memory, from particular address, whatever data is there, that data is going to store into the DR, and that data and the data stored in the accumulator. AND operation is going to perform between these two things, and final answer is going to store into the accumulator. Okay. So this is the AND operation. It is going to complete up to the T5 signals. The next memory reference instruction, add. For the add, D1 is going to select. First, read the data from memory and store the data into the DR. After that, do the addition operation between the data stored on the DR and the data stored in the accumulator, and store the result into the accumulator. If any carry is going to generate, then store that carry into E. And after completion of each operation, sequential counter must be 0. Now, next memory reference instruction, load AC. That means put the data into the AC. So from where you have to put the data into the AC? Then the in the memory address stored in the AR register take the data from that memory to DR and copy the data from DR to AC. So indirectly, the memory of AR it is going to copy into the accumulator. Next operation exactly reverse store accumulator. Data of accumulator is going to store at particular address given in the memory. Next is branch unconditionally. Generally program counter is incremented by 1. But if you want to do the branching, then the data of AR is going to copy into the PC. So PC is not incremented by the value 1, but it is incremented by the value of PC. It is moved on the value of AR. Next, branch and save return address. So branching is there and save the return address. Okay, both. So the memory of program, the values to of program counter is going to store in at some place at in the memory. Okay, so at in memory at particular address register value, the value of program counter is going to store, and then it is incremented. Okay, now that particular value of AR once again it is stored into the PC. Okay, so that is called the branching, and the returning address is going to store in AR. Okay, increment and skip if 0. So memory of AR is going to copy into the DR. DR is incremented by 1. Okay, but one more thing is that memory of AR, DR is going to copy into the memory of AR. If DR is equal to 0, then program counter is equal to program counter plus 1. That means if the DR is equal to 0, then program counter is going to increase. Okay, and if DR is a non-zero value, then it is not going to increase. So increment and skip if 0. Now this is a flowchart for the memory reference instruction. Here we are going to display these all the operations which we have discussed right now. AND operation, add operation, load, store, branch unconditionally, branch and save return address, increment and skip if 0. Now next is input output configuration. Here these are the input and output terminals: keyboard input terminal, printer output terminal. These are the serial communication interface, transmitter interface, receiver interface, and these are the computer registers and flip-flops. Now how it works. For example, if you are going to press any key from the keyboard, and here these are the flag FGI, FGC. FGI in the default case it is 0 by default. The value of FGI is equal to 0. What it is going to indicate? That input register is free now. It is empty. So when the value of FGI is equal to 0, at that time input register is empty. So at that time on the input terminal, if any data is going to come, then from this transmitter interface it is it comes into the input register. So when the input register is full, at that time the value of FGI that will be 1. That 1 indicate that the input register is full. Okay. So now it is not able to take any more data from this transmitter interface to input register. Now any other data have to come in this input register, then have to wait. Okay. Now when the data is going to pass from input register to accumulator, at that time once again it is free and the value of FGI is equal to 0. And now input register is able to take the next data. Now about this output register. The default value of FGO, that is 1. 1, that means out R is empty. Okay. Out R is empty, then it is able to take the data from the accumulator. Now when out R is full, at that time FG0 that will be FGO that will be 0. 0, that means out R is full. So it is not able to take the next data from accumulator. Okay. When this out R is going to pass the data to the serial communication interface to the output terminal, at the same time the value of FGO, that is 1. So now out R is empty and able to take the another data. Okay. So this is one type of serial communication path for the input and output configuration. Next is interrupt cycle. Basically, while the computer is running the program, and if there is no error, then it is directly going to execute the instruction. But if any error occurs, then it has to move in the interrupt cycle. Now see here, the value of R interrupt cycle is based on the value of register R. Okay, when the value of R is equal to 0, at that time computer goes through the instruction cycle. During the execution phase of the instruction cycle, this is the execution phase of the instruction cycle. It is going to check the value of IEN. Okay. The value of IEN that is checked by the control. If the IEN is 0, it indicates the program does not want to use the interrupt and simply the execution is going on. So control continue with the next instruction cycle. But the other option is if the IN is equal to 1. So if the IN is equal to 1, the control checks the flag bit FGI and FGO. If both bits are 0, then indicate that neither the input nor the output register are ready to transfer of information. Once again, if the value of IN is equal to 1 and both the flags are 0, FGI and FGO, if these both the flags are 0, it indicates that neither the input nor the output registers are ready for transfer of the information. And at the end of this interrupt cycle, once again it is going to check the value of R. If the value of R is equal to 1, so if the value of this both flag are 1, then the value of R will be 1. So when the R will be 1 and it once again comes over here. If the R is equal to 1, then it is going to execute the interrupt cycle. Okay? The interrupt cycle, that is basically the hardware implementation of a branch and save the return address operation. The return address that is available in the program counter, that is stored in specific location where it can be found later when the program returns to the instruction at which it was interrupted. Okay? So basically this, it is going to store the return address at location 0 and branch to location 1. Then interrupt is going to solve and the value of r will be 0. Once again it come here when the value of r is equal to 0. So once again it is going through the instruction cycle. We're going to solve the instructions like this. Okay, like this. Okay, and if an interrupt is there, then r is equal to 1, then it is going to solve the interrupt cycle. Once again, after solving the interrupt, come over here and going to solve the instruction cycles. Okay, the last topic is complete computer description. So basically, it is a combination of the instruction cycle and the interrupt cycle. Okay, now which one is the instruction cycle? So we have discussed, this is the instruction cycle. Okay, and which one is the interrupt cycle? Then this is the interrupt cycle. So in the computer description, here there is an interrupt cycle, logic of interrupt cycle, and here the logic of an instruction cycle. Okay. So in a normal case, the value of r, that is 0, and it is going to solve the instruction cycle. Okay, like this. Like this, it is going to solve the instruction cycle. But if any interrupt is going to generate, then the value of r is equal to 1. Then it is going to, it runs through interrupt cycle and the value of r will be 0. Once again come here, when the value of r will be 0, it is going to solve the instruction cycle. Thank you.